Why you should learn it? The depreciation D in millions of dollars of the WD-40 company assets from 2009 through 2013 can be approximated by the function d of t is equal to 1.9 square root of t plus 3.7, where t equal to 0 represent 2009, and those are the sources of WD-40 company. A said to describe the transformation of the parent function f of t is equal to the square root of t. So now let me go to the next function. So this is a, and we have a d of t. This is the function was d of t is equal with 1.9. So just let me go back and see again. 1.9 t plus 3.7. 1.9 square root of t plus 3.7. So just let me erase that. T plus 3.7. And we wanted to compare with the parent function f of t. F of t is equal to the square root of t. So this is the parent function, and we want to compare with the parent function the function that is described the production in the WD company. So now, as we see here is 1.9. 1.9, it means that this is a stretching factor because it's a greater than 1. The graph of the function is going to stretch vertically with the factor 1.9. The parent function is going to stretch with a factor 1.9 vertically, the graph of the function, of the parent function. Then what's happening in the parent function, it translates horizontally 3.7 units to the left in this side, because the parent function here was something like this. This is the parent function f, and this is parent function d of t. d of t. So this is a graph of the function d of t, and this is the function of the graph. So it means it was stretched vertically a little bit for the factor 1.9, and it has a horizontal translation for 3.7 units to the left. So this is what is happening under the A, or what was the transformation of the parent function. So now we are going to answer on the B. Use the graph in utilities to graph the model over the interval from 0, smaller or equal to t, and smaller to equal to 4. We already have the function here, and we want to look at this window from 0. From 0 is up to here, and 4 is up to here. So here is 2009, in 1 here is 2010, 2011, 2012, and here is 2013. This is a 2013. So the window t from 0 and t to 4 we already have here. This is a 4, and this is a 0 in this interval. Represent from 2009, the product of the company is from 2009 to 2013. And C, let me see what is asking for C. C says, according to the model, in what year will the depreciation of WD-40 assessed be approximately $6 million. Because of this function represents the depreciation, then we are looking at how much is going to be depreciation, $6 million in what year. So now in the 2009, we already see here was a $3.7 million. $3.7 million. In 2010, it was a little bit bigger. And for example, here in 2003, it was $5 million. But we are looking for a $6 million. And which year could be $6 million? Here is a 6. Here is a 6. And I'm going horizontally here. And I'm going to see where it's going to intercept in a 6. And in 6 is going to intercept here. And if we go in here, is approximately is going to be to the number 6 down. This is a 6. But we already know here is 2009, 2010, 11, 12, 13. In a 5 is 2014. And in the 6 is a 2015. So in a 2015, in a 2015, in the depreciation in 2015 is going to be around $6 million. So in 2015, so this is a 2015. The depreciation is going to be $6 million. Now in a D, we go in a D to see what is a D. And this says rewrite the function so that 0 represent 2011. Explain how you got your answer. And now here is 2010, 2011. 2011 is here. So in order for us to make this 2011 in a 0, we have to move this function for 2 units. For 2 units we have to move. We move this function for 2 units, 1 unit, 2 unit, and then interception is going to be here somewhere. This graph is going to be intercepted here. But how we can write the formula? Because I am moving to the left, it means if I have a d of t, and according to the rules of a horizontal shift of the graph of the function, if I'm going to the left, here is 1.9. I'm not changing nothing because the stretch is going to be the same. The graph is going to be the same. We have just a translation of the graph. And here is going to be t plus 2 because I'm shifting to the left 2 units. I'm writing here 2 plus 2. T plus 2 plus 3.7. 3.7. And now if I'm rearranging a little bit better this function is going to look this way. D of t is equal to 1.9 times square root of t plus 2 plus 3.7 is equal to this plus 5.7. So this is the final answer to describe the graph how it's going. For example, if we are starting from 2011, if we are starting on the D, what it says to rewrite the function that t equal to 0 represent 2011 is this function here. And now if we are plugging here a 0, it means it's going to to intersect here somewhere. So basically this is the graph of the function.